Hey makers, welcome back to Hub360 Embedded Sphere, your home for smart robotics and affordable electronics projects. Today we are building a two-wheel drive line following robot using Arduino DRV8833 motor driver and two line sensors. This robot automatically follows a black line on a white surface using infrared line following sensors. It's simple, fast, and perfect for beginners getting into robotics. Here are the components used in this project: Arduino Nano, a DRV8833 motor driver, two DC geared motor, two line following sensors, and battery pack with jumper wires. Now let's dive into the connections. We connect the Arduino to our line sensors. Connect the Arduino 5 voltage pin to line sensor VCC. We connect Arduino ground to line sensor ground. Okay, we start by connecting Arduino 5 voltage to line sensor VCC. And then we connect Arduino ground to line sensor ground. Then go ahead and connect the data pin of the sensor, the line sensor, to Arduino D2 pin. Now you connect the other sensor to Arduino D3 pin. Now let's go ahead and connect the Arduino to the DRV motor driver. This is the DRV motor driver. Connect D9 on the Arduino Nano to DRV in 1 pin. And you connect the D10 pin on the Arduino Nano to DRV in 2 pin. Then go ahead and connect the D5 pin on the Arduino Nano to in 3 on the motor driver. And we connect the D6 pin on the Arduino Nano to in 4 on the motor driver. Now you go ahead and connect the motor driver to the motors. So you connect the motor driver out 1 pin to the left motor. And we also connect the motor driver out 2 pin to the left motor as well. Go ahead and connect the motor driver out 3 pin and out 4 pin to the right motor. So now we connect the battery positive to our DRV. And connect the battery negative to our DRV as well. So make sure your Arduino GND and the motor driver GND are sharing the same ground. And then you connect the EEP pin or the enable pin on the motor driver to your 5 voltage pin on the Arduino Nano. Now let me explain the code. This section on here, the pins read the left and right line sensors. High for white surface and low for black line. These pins here control the DRV motor driver. The A in 1 and A in 2 for the left motor and B in 1 and B in 2 for the right motor. Each motor uses 2 pins for direction and speed control. Then the speed variable section. The base speed is normal forward speed. The turn speed is reduced speed used during turns, and slowing one motor helps the robot turn smoothly. Values range from 0 to 255. Then we go to the setup function. In the setup function, the sensors are inputs. The motor driver pins are outputs. No serial begins needed since we are not debugging here. In the main loop section, it reads sensor value continuously, stored in left and right. Then forward movement. Both sensors see white surface. Robot is centered on the line. It moves forward. Then to turn left, right sensor sees black line. Robot drifts to the right. Slow right motor. It now turns right. Then the stop condition. Both sensors are seeing black. Then possible junction or end of track. That is what it reads. Then it stops motor. That's the behavior. So in the motor control functions, we have forward motion. We have turn left, turn right, and stop motors. In this section, both motors brake. Robot stops safely. Now let's see the robot in action. Alright, here are some calibration tips. Before running the robot, always calibrate the line sensor using the potentiometer. Good calibration makes the difference between a shaky robot and a smooth one. If you're enjoying this build, don't forget to like, subscribe and share. More robotics projects coming your way on Hub360 Embedded Sphere. Thanks for watching. I'll see you in the next build.